Okay, so we are going to look at daily practice, forces with motion analysis number 5. And this is a longer one, so it reads, you notice a bunch of friends playing outside with a sled, pulling each other. One friend is pulling the sled purely horizontal with a force of 35 newtons. The other friend is pushing the sled purely horizontal with a force of 20 newtons. And the friend riding on the sled is dragging his feet on the wheels or on the ground, causing a horizontal force of 15 newtons. The friend riding the sled and the sled have a combined mass of 95 kilograms. We're going to neglect friction in this case. If the sled started from rest, how fast is it going after it travels 3 seconds? Okay, so we're interested in how fast. That's a descriptor of motion. We're going to start with kinematics. So, since we're interested in the how fast, that's just describing motion. So, what is our object? Well, it's the sled that we're describing the motion of. When does that motion we care about begin? When does it end? It says when it starts from rest, so after we get that object moving, how fast is it going after 3 seconds? So when it starts to move, 2, 3 seconds later is when we are done carrying. All right, so here's our sled. We got a lot of people interacting with it. We'll just leave that sled plain. And of course, I have to identify the origin. I'll identify that as the location of the sled. All right, so we make our list. Initial and final positions. Initial and final velocities, accelerations, and time. So our initial position, the sled is starting from starting at the origin. We'll call that our initial position of 0. Final position, we don't know. Initial velocity, it says it starts from rest, so that's at 0 meters per second. We don't know the final velocity. We're not given the acceleration, but we are told that the sled goes for 3 seconds. So what are we interested in determining? The question is saying how fast? How fast is the final velocity after those 3 seconds? So we're going to use our velocity relationship, which tells us that the final velocity is equal to the initial velocity plus the acceleration times time. Our final velocity is what we want to know, so we don't know it. It stays as final velocity. Initial velocity is 0. Acceleration, we don't know that. And our time is 3. So our final velocity is 3 times the acceleration. But I don't know the acceleration. So it then becomes a variable of interest. Well, since I don't know x final, I'm not going to be able to get that acceleration through kinematics. But accelerations are caused by forces. So perhaps since I need the horizontal acceleration, I can look at forces. So let's examine the forces acting on this object. All the interactions, and then developing the free body diagram. So our first interaction, well, we always know that gravity exists. That's going to be between the sled and the earth. So as I develop my free body diagram, I will put on my force of gravity and just remind us that that's mg, which is also equal to the weight. Okay, another interaction. Well, the sled's sitting on the ground. So we know that it is squishing those ground molecules and they are pushing back. So we have the sled and the ground. That's in the vertical direction. And it is a normal force, a type of normal force. Right? I might start to think about if there are any other forces vertically. I like to sort of think of my forces in its 2 dimensions because I'm going to separate them anyway, so thinking about them. I don't think there's anything else vertical, so I'm going to predict and draw my free body diagram with these 2 forces being equal since there's nothing changing in the vertical dimension. Right, additional interactions. We have 3 friends interacting with this sled. We have friend 1 between the sled and the friend 1. We have friend 2 between the sled and friend 2. And then we'll use blue again. We have friend 3 between the sled and friend 3. All right, so how do those look on our free body diagram? Well, let's say friend 1 is pulling the sled. So friend 1 is going to be pulling the sled. We're going to have the sled move in this direction. So we have friend 1. Friend 1 is pulling at 35 newtons. Friend 2 is pushing, and we'll say it's helping the push, at 20 newtons. So not as long as my 35. But there's friend 2. And then the guy sitting on the sled, friend 3, he's sort of dragging his feet. So he's making it difficult to push that sled. So at 15 newtons, we'll say this is friend 3. So we have 5 forces acting on this object, and we're interested in how those forces cause the acceleration that I need to know how fast I'm going. So we will delineate those forces into their, let's keep F1 and F2 what it is. Force 1, force 2, force 3, we'll say this one is force 4 and force 5, just to help keep that numbering simple. So we separate these forces into their horizontal and vertical dimensions. So force 1 is going to be our force 1. It's to the right, so it is positive. Force 1, nothing in the vertical direction. Force 2 is also to the right. It's also positive, and nothing in the vertical direction. Force 3 is to the left, so it'll be negative. It's horizontal, so there's nothing in the vertical direction. All right, force 4 is our force of gravity. It does not have anything horizontal. It's pointing down, so it's negative. There's our force of gravity. And our 5th and final force is the normal force. It's pointing straight up, so nothing horizontal and positive in the vertical direction. So all 5 forces on our list, and now we can apply Newton's second law. That, remember, tells us that the sum of the forces horizontally is equal to the mass times the horizontal acceleration, and the sum of the forces vertically is the mass times the vertical acceleration. All right, well, I'm interested in that horizontal acceleration, so I'm going to really focus on, to begin with anyway, that horizontal list. I'm going to sum those forces up. So I have a positive force 1, a positive force 2, a negative force 3, 2 zeros, and that's going to equal my mass times my acceleration horizontally. Now force 1, we were told, was 35 newtons. Force 2 is 20 newtons. Force 3 is 15 newtons, and the mass of our sled and person is 95. So now I can solve for my horizontal acceleration, and I get 0.42 meters per second squared is equal to my horizontal acceleration. That's what I needed. I already need to worry about the vertical list. I can take this horizontal acceleration and use it to find my final velocity. So V final is equal to 3 times 0.42. At the end of that 3 seconds, my buddy in his sled is going 1.26 meters per second squared. Meters per second, not seconds squared. Okay, so again, interested in final velocity. We tackle it with kinematics. Kinematics tells us we need acceleration. Recognizing that link between the acceleration and the forces, forces cause that acceleration, so we do a force analysis to see what those forces are causing, what acceleration they are causing, and then we can use that acceleration to finish our analysis. Good job.